Hey guys, this video is going to be about solution stoichiometry. I know y'all are all excited to get back into it, so let's do this thing. All right. So when you're going from one substance to another substance, you have to use the mole to mole ratio found in the reaction. So for all of you, it's been a while. If this is my reaction, what would that be? 2AB. All right, the mole to mole ratio of A to AB is 1 to 2, right? Because with one of these, 1 mole of A2 reacts with 2 moles of B to give us 2AB. So if we're just looking at A to AB, then that's 1 to 2. So that's a mole to mole ratio. And to use a mole to mole ratio, you have to have the unit of moles. So if you're given grams, you have to get into moles first. So that is this right here. We use molar mass to go back and forth between grams and moles. All right, and we're always going to start with the substance that we know the very most about, with the number that does not have a unit in the denominator. Molarity can be used to go back and forth between moles and liters. All right, and it has the unit liters in the bottom. And then this middle one is a mole to mole ratio, so moles of A to moles of B, or moles of B to moles of A. Right? So the mole to mole ratio from that reaction that I wrote up top would be 1 to 2. 1 mole of A to 2 moles of B. All right? Okay, so let's try some of these. It's really best if you just learn by example. How many milliliters of 0.28 molar barium nitrate are required to precipitate as barium sulfate all of the sulfate ions from 25 milliliters of 0.350 molar aluminum sulfate? So I've given you the reaction here. And we know most about aluminum sulfate, and we're looking for something about barium nitrate, right? We're looking for milliliters of barium nitrate. So I'm just going to write that right here. Okay, and so I've got 25 milliliters of 0.35 molar aluminum sulfate, and molar means molarity, so that actually can be written 0.350 moles of aluminum sulfate in every liter of solution, right? So this has a denominator in the unit, so we're not going to start with that. We're going to start with milliliters, all right? And I'm going to show you how I work this problem, but you can work it a different way, and I'll talk about that in just a minute. We've got 25 milliliters of this solution, so I'm just going to leave it in milliliters. And there's 0.350 moles of aluminum sulfate per liter of solution. The only connection between aluminum sulfate and barium nitrate is the reaction, the chemical reaction right here. So in order for me to get from aluminum sulfate to barium nitrate, I have to use a mole to mole ratio. That's how I can change substances, right? So to change substances, you should have that written down from the first screen. You have to use a mole to mole ratio. So I can use 1 to 3. So I'm going to put 1 mole of aluminum sulfate to 3 moles of barium nitrate. Now that I have moles of barium nitrate, I can use my molarity of barium nitrate to get back to liters. So it says that I have 0.280 moles of barium nitrate for every single liter of solution. So I'm just going to flip that over and say 0.280 moles of barium nitrate per every liter of the barium nitrate solution. So I had to flip this one over right here because I wanted to cancel out moles of barium nitrate here, right? So you still have to cancel out your units the same way, and moles of barium nitrate can only be canceled by moles of barium nitrate, all right? So when I go to cancel out my units, liters cancel, moles of aluminum sulfate cancel, moles of barium nitrate cancel, and I'm left with milliliters. So that's going to give me the milliliters of the barium nitrate solution that I was looking for. And so my answer is going to be 93.75 milliliters or 93.8 milliliters because my significant figures is 3. Right, there's 3 significant figures. All right, so you could have turned this into liters if that's the way that you see it, but then you'd have to turn this into milliliters. So I just left it here because I knew I was looking for milliliters. That comes with experience and just seeing it. Either way, you're going to get the same answer. All right, second example, how many grams of a precipitate will form when 150 milliliters of 0.5 molar silver nitrate, which is this one, are added to 100 milliliters of 0.4 molar potassium chromate. So the precipitate is going to be the silver chromate because it's the solid. All right, so I basically want to go from silver nitrate to silver chromate, and then I also have to go from potassium chromate to silver chromate and figure out which one is my limiting reactant, which one is going to be used up, right? It's also the same one that runs out first. So it's the one that determines how much product is going to be formed. So I'm going to start with, you can start with either one of these. I'm going to start with silver nitrate because it was given to me first. All right, and this one, since I'm going to grams, I'm going to go ahead and convert my milliliters to liters. So if I have 150 milliliters, then that means I've got 0.150 liters. You just divide it by 1,000 to get to liters because there's 1,000 milliliters in 1 liter. And I've got 0.5 moles per liter of the silver nitrate. So in order for me to go from silver nitrate to silver chromate, I have to use a mole-to-mole ratio. And my mole-to-mole ratio is going to be 2 moles of silver nitrate. And I put that on the bottom so that it would cancel with this one up here on the top. And that gives me 1 mole of silver chromate. Since I'm looking for grams of silver chromate, the molar mass of silver chromate is 332 grams per mole. All right, so moles of silver chromate will cancel with moles of silver chromate, moles of silver nitrate with moles of silver nitrate, and then liters of silver nitrate solution with liters of silver nitrate solution. So for this one, I end up getting 12.45 grams of silver chromate. And then I have to still do this other one. So I have 0.1 liters of the potassium chromate solution, so I have to use the molarity of that because this is of that solution. And I have 0.4 moles potassium chromate per liter, right? And I remember I went ahead and put this into liters by dividing by 1,000 because I knew I had to go to grams. And the mole-to-mole ratio of potassium chromate to silver chromate is going to be 1:1. Then I can use my molar mass of silver chromate. And I'm just using whole numbers here to make it easier to fit on the screen so you can see what's happening. All right, so moles of silver chromate cancel with moles of silver chromate, potassium chromate with potassium chromate, liters with liters, and I end up with 13.28 grams. So since the silver nitrate solution could only make 12.45 grams of silver chromate, then that would be the amount that would form of silver chromate. And that tells me also that silver nitrate is the limiting reagent. Okay, so this could not be formed because after we form 12.45 grams of silver chromate, we're completely out of silver nitrate. And if you don't have any of this, you can't make this because all the silver ions are gone. This example says we have 25 milliliters of hydrochloric acid solution and it requires 24.16 milliliters of 0.106 molar sodium hydroxide during titration. So a titration is where we have this, it's called a burette. All right, and we're adding a titrant to a sample. So in here we would have our hydrochloric acid, 25 milliliters of it, and we're slowly adding the base until we get an equivalence point. And we will talk about that in class more, where we do the lab. We'll do a couple of these throughout the year. And it says that it took 24.16 of this 0.106 molar sodium hydroxide solution to complete the titration. So we're just going to use the data to do the math, and you'll see how it works more in class when we can actually perform a titration. All right, so I'm going to start with this information here because I have the most of that, right? You always start with what you have the most of, and we're going to end with this. All right, so I've got 24.16 milliliter, and I'm going to start with this number instead of this one because this molarity is really moles per liter. You always start with the units that don't have a denominator. So I'm going to start with 24.16 milliliters of sodium hydroxide. And then I'm going to use the molarity, and moles has to go in the top because I want it to cancel out the liters that we started with. Okay, so liters of NaOH will cancel with liters of NaOH. I still have this milli here. And you could convert it to liters at the beginning if you wanted to. It's not going to really make a difference. Now I want to go from sodium hydroxide to hydrochloric acid. There's one of these for every one of these. So it's a 1-to-1 mole ratio. And I have to put sodium hydroxide on the bottom so that it cancels with the sodium hydroxide up here on the top. Now I have my moles of HCl, and it says I want to find the concentration, right? I'm looking for concentration. And concentration is in the units of moles per liter. So I need to find the moles and then divide it by the liters. Well, I've got the liters. I've got the liters right here, right? So I just need to find the moles, and I have it right here with this setup. All right, so I've got 24.16 times 0.106. That's going to give me 2.56096 millimoles of HCl, right? Because moles of NaOH cancel with moles of NaOH, liters cancel with liters. I still have that milli, so it's millimoles that are left over. And I'm going to divide that mole by the 25 milliliters that I started with. So what ends up happening here is milli cancels with milli, and I'm left with moles per liter, which is this molarity. When I divide that, I end up getting 0.102 molar HCl. Okay, now if you would have changed this to liters, then you would have ended up getting moles over here, right? Not millimoles. It would have just been moles if you changed this to liters. So then you would have had to divide by liters, not milliliters, because the milli wouldn't cancel out if you didn't do that. You would end up with the wrong answer. All right, so it all depends on how comfortable you feel with milli, if you want to use it like this or not. So those are all the examples that I have for this one. I'm doing a couple more in the next video. I didn't want to put too many in one in case you were short on time to watch them. So there's some more examples coming over the same type of problems, and we're going to do some really short labs in class that kind of cover this. So hopefully you get some hands-on experience. This does take a little bit of work, just like when you learn stoichiometry for the first time. We're just using molarity in it now too.